All right, let's look at the power series method. All right, let's dive right into an example. All right, problem number 3, 2y prime plus 3y equals to 0. All right, so let's use power series to solve this differential equation. All right, so here, y prime, so we're going to put the corresponding power series for that. So I'm going to have, all right, it's going to be 2 times, all right, so we have a summation. Actually, I messed up something here. This actually starts from 1, so I have to change that. All right, then here you have n starts from 1 to infinity, n cn x to the n minus 1. Right, so that's y prime, and plus 3 times y is just a summation. N goes from 0 to infinity, Cn x to the n, and this is equal to 0. All right, so what we want to do is we want to combine two summations together so that we have only a single summation. It's a little easier. All right, so in order to do that, I want to match these powers. So this one has a power n, right? This one has a power n minus 1. So we want to match that. So what I can do is here, instead of starting from 1, I'm going to actually stop from 0. So I'm going to shift the index by 1 notch. So what happens is, since n starts from 1 smaller than the original number, so I have to change the index. We can just add 1 to the index. So we have n becomes n plus 1. So Cn becomes Cn plus 1. Then x to the n minus 1 becomes x to the n, which is kind of what we wanted. All right, then we like the way it looks on the other one, so it's going to be 3 times summation, n goes from 0 to infinity, Cn x to the n is equal to 0. All right, so now we have exactly the same summation and the x to the n, so we're going to combine those two together. So we're going to have, right, so you have a summation, right, n goes from 0 to infinity, so I'll just write it once. So we combine those two summations together. Oh, actually just a summation sign as 1. So I'm going to put that there, and this guy pulled out here. All right. Then also we have x to the n. So x to the n is right here, and x to the n right here. So there's no point of writing it twice. So I'm going to just pull those guys out, and I'm going to write it once. So you have x to the n here. All right. Then we write down the coefficient. So coefficient is going to be, right, you have a 2 times quantity n plus 1 times Cn plus 1, all right, from the first term. And then you're going to have a plus 3Cn. All right, so this is equal to 0. All right. So in order for this power series to become 0, you have to make sure that each coefficient is equal to 0. So we can actually set this guy equal to 0. All right. So what you get is going to be this condition. All right. So you're going to have, let's say, 2n plus 1, Cn plus 1. All right, I'm going to put the 3Cn on the other side by subtracting 3Cn here. So it's going to be negative 3Cn. All right, then I'm going to just divide through by 2 times n plus 1. So Cn plus 1 can be written as negative 3 over 2 times n plus 1 Cn. right? So we got some condition about the unknown coefficient, right? Let's try to find out what they are, right? So let's try n equals 0. So I'm going to just let's try just plug in n equal to 0, right? See what they are. So which means that when n equals 0, C1 is equal to, n is 0, so you're going to have, let's see, negative 3 over 2. Then you have a C0, right? All right, then how about the n equals 1? Well, n equals 1, we get C2 is equal to, right, negative 3 over 2 times another 2 and C1, right? But what we're going to do is we're going to actually put C1 is actually this guy. So I'm going to plug this guy in here, right? So what we get is going to be, all right, so we're going to have, let's see, so you have negative 2/3, sorry, 3/2. So negative 3/2, right? You have 2 of these, right? And then you're dividing by extra 2. So I'm going to just divide by 2. Then you have a C0, right? So that's what it looks like, all right? Then let's do another one. Try to see if we can see a pattern here. So n equals 2. So C3 can be written as negative 3 over, right, 2 times, right, it's times 3, right, C2, right? But C2, we just found out that this is C2, so I'm going to plug this guy in here, right? Then you see that you have another negative 3/2 over 2. Then you have 2 times 3. So I'm going to actually write the 2 times 3 as 3 factorial. So 3 factorial, right? Then this is going to be C0, right? Then here, 2 is the same as 2 factorial. So I'm going to just put 2 factorial. And here, this one, I'm going to try to see the pattern here. I'm going to write it as a negative 3 over 2 over 1 factorial is 1, so over 1 really doesn't do anything, and it's C0. All right? So now we're seeing a pattern. Then we say, I'm seeing the pattern. So if we were to come up with the formula for Cn, all right, here. Oh, this is going to be 3 right there. All right, so you can see that this is going to be negative 3 over 2 is already there. And the index is the same as power, so you're going to put the nth power here. And you have a factorial, but the index factorial. So index is n in this case, so n factorial. Then everyone seems to have a C0 there. All right, so what you get is this. Remember that the y, so y is the power series, summation, n goes from 0 to infinity, right? So Cn looks like this. So I'm going to write, I'm going to put the Cn in here. So negative 3 over 2 to the n over n factorial C0. Then you have x to the n, right? So let me do a little bit of rearranging so that we can recognize this function. All right, so this is going to be equal to, right, so we have a summation, n goes from 0 to infinity. All right, I'm going to put the C0 outside since it's just a number. All right, then here we're going to have I'm going to combine negative 3 halves and x to the n together. So you have a negative 3 halves x, and raise it to the nth power, because both of these guys have an nth power, and over n factorial. Right? So remember the power series for exponential function? If you write down the power series of exponential function, it looks like this. E to the x is summation. N goes from 0 to infinity, and x to the n over n factorial. Right? Here, only difference is we have negative 3 halves x instead of x. So therefore, this is actually, right, so we have a solution. Y is equal to, right, C0 is just any number, so I'm going to put C0. So this is the exponential function with negative 3 halves x inside. Right? So we have that. All right, then so this is a solution. So we found the solution using a power series method. And here, oops, I'm gonna just box this guy in. All right, and what would be the radius of convergence of this power series? All right, so remember that the radius of convergence, all you have to do is let's see. All right, radius of convergence r. Oops, sorry, I keep on doing this. Right, r is limit of absolute value of Cn, which is this guy. So I'm going to just write negative 3 over 2 to the n over n factorial, and we have a C0. And divided by Cn plus 1. So I'm going to just write the reciprocal. So you're going to have n plus 1 factorial over negative 3 halves to the n plus 1. And then C0 is going to be on the bottom because it's a reciprocal dividing by. All right, so we can simplify. So C0 on top and C0 on the bottom cancel out. And negative 3 over 2 to the n cancel with this guy, and you have a 1 left over here. And remember that here n plus 1 factorial is same thing as n plus 1 times n factorial. So we can cancel n factorial here, n factorial there. All right, then what you get is going to be here. Right, we have a number, negative 3 over 2 on the bottom, so which is the same thing as negative 3 halves, which is just a number. With the absolute value, it becomes 2/3 outside. And then we have a limit as n approaches infinity. I forgot to write that. Right, so you're going to have, only thing that's left is n plus 1. Right, but as n goes to infinity, n plus 1 goes to infinity. So this, in this case, the radius of convergence is infinity as well. All right, that's it. I hope that this was clear.